Okay, we're going to evaluate some logarithms without using our calculator. So these are all ones we can do without a calculator. You're going to need this to do some of your homework. So if you're still confused after watching the last video, hopefully this will clear it up. So if you remember in our last video, we said that this little expression that we're looking at here basically says if I have an exponential expression with a base 4 and it yields a result of 16, this is asking me what exponent should I use? So what exponent can I raise 4 to get 16? So remember, that's what we're trying to do here, right? So basically it says if I have 4 to the something, that has to equal 16. And then you can solve these just like you've been thinking about these exponential equations that we were looking at the other day. We can rewrite this as something with the same base, right? So 4 to the something has to equal 4 squared. Well, obviously these two things have to be the same. So this whole expression has to be equal to 2 because that's what the logarithm is. It's the value of that exponent that we have to raise that base to get this value. Okay, so let's look at this one. This one is the same thing, only this time we're asking about if the base were a 2, what will we have to raise 16 to get that? Well, think about it the same way. 2 to the what has to equal 2 to the, well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is a 4. So in this case, the whole expression, this log is the same value as this little question mark. So this one has to be a 4. Okay, let's just do a couple more and then we'll look at some maybe a little bit more tricky ones. Again, this says 5 to the what has to be equal to 125. Well, hopefully everybody knows that 125 is 5 times 5 times 5, so this one would be a 3, right? And we said this one over here we looked at the other day on the other video, this one, 6 to the what is going to give me a 1. Well, what does this have to be to get a 1? Hopefully everybody remembers that that one is 0, right? Let's look at this one. 6 to the what is equal to 6. Well, clearly that means that it is a 1 because there's a 1 here that we don't usually write. This one is a 1. And how about this guy? We have log base 6 to the what is equal to 6 to the 5th. That's the easiest one so far because the answer is staring us right in the face before we even get started. It's clearly a 5. Okay? Now let's look at these ones that maybe are not quite as straightforward as those ones. Those ones most of us can do because we know a little bit about numbers. We have a little bit of number sense. But let's take a look at these ones that maybe are a little bit trickier. Okay? We're going to set them up the same way. This says we have a base of 81 and we're going to raise it to something. So you can use whatever you want to denote that something. You can use an X, a question mark, a Y, whatever letter you like. And that's going to be equal to 27. So now I can think about this the same way I was thinking about my exponential equations that we were just doing the other day. And I can try to think about how to change these things to the same base maybe. So what base would I use here? I would use a 3. I would change my 81 to 3 to the 3 times 3 is 9 times 3 is 27 times 3 is 81. So that means it's a 4. And that whole thing has to be raised to something to equal this other side. And what is this other side going to be? 3 to the 3rd, right? So really, what this is saying is these two exponents have to be the same value, right? So we know that 4x, and why do I write it as 4x? Because we're raising a power to a power, so we're multiplying, has to be equal to 3. So what does that x have to be equal to? It has to be equal to 3/4. Does that make sense? So this whole expression is equal to 3/4. Okay, let's try it with this other one. So this one says, my base is 27, and I'm trying to get it to be 81 by using exponents. So base 27 raised to something has to be 81. Again, what is a good base to use for these? Well, probably the same one we just used, right? 3. So we said this was 3 to the 3rd, and this was 3 to the 4th. And in this case, Now we're talking about these exponents, right? So this time we could say that 3x is equal to 4, or in other words, x is equal to 4/3 in this case. Okay? We'll do a few more examples just so that we have it seared in our brain. Let's take a look at this one. This says 216 to the something has to come out to be a 6. Log base 216 raised to some exponent, this exponent, is going to give me a 6. 216, maybe you don't know, but that's 6 to the 3rd to the x. So now, what exponent do we imagine is here? We imagine it being 1. So this says 3x is equal to 1, so x must be equal to 1/3. And if we switch it around this way, right, this one says something just a little different. This says 6 to the x is equal to 216. So 6 to the x is equal to 6 to the 3rd. So obviously we have a 3. And hopefully you know this whole thing. I didn't write it here, but that's equal to 1/3. So my x in this one is standing for this whole expression. These two things are the same, right? I'm letting the x equal that little expression log 216. Log base 216 to the 6. All right, here we go again. Ready? We're going to use our famous 216 again. So 216 to the x has to come out to be a 36 this time, which means 216, well, I guess let's change it to 6, right? 6 to the 3rd to the x, because we know that's where we're headed with this, right? Because we've seen them already. 6 squared, that means 3x has to equal 2, so x has to equal 2/3. And hopefully you can see these are all kind of the same thing, right? Oh, this is exactly the same thing. So let's not bother with it. Let's do this one instead. What if I switched it to this instead? This would say 36 raised to the what has to equal 216, while 6 squared to the x has to equal 6 to the 3rd. So this one is 2x has to equal 3. So x has to equal 3/2. So it doesn't matter what the base is. You can just rewrite them and look at them like you did your exponential equations, right? Again, all the same. 625 to the what has to equal 5. So 5 to the 3rd. Oh, sorry, that's the 4th. That's 5 to the 4th. 5 to the 3rd is only 125. So this says 4x is equal to 1. X has to be equal to 1/4. So this whole thing has to be equal to 1/4. Okay? Everyone see what we're doing? We'll finish up these last two since they're here. This one says 625 to the x has to equal 125. So 5 to the 4th raised to the x has to come out to be 5 to the 3rd. So 4x has to equal 3. X has to equal 3/4. Now remember, when we have these fractions, we're talking, when we have these fractions, we're talking about radicals, right? So it's saying that 625 is the same as the 4th power of 125 to the 3rd. Okay, so, oh boy, I did it wrong. That's not at all what it says. This one's supposed to be the 625. And this one's supposed to be the 125. There we go. Now it's right. Okay, and so let's do this one because we're talking about this being raised to the exponent, right? This is the exponent with the 3/4. So this is the thing being raised to 3/4. The x is 3/4, not the 125. That one does not have an exponent of 3/4. Okay, let's do this one. This one will be the one that has the exponent, the 125. So I guess it's kind of good that I made that mistake because you can see that's an easy mistake to make when our hands are working faster than our brains, right? Sometimes. All right, this is 5 to the 4th. And this one says 3x has to equal 4. So x has to equal 4/3. And I'm kind of running out of paper here. And this one says that 125 is the thing that has the exponent this time to the 4/3. So that's equal to the cubed root of 125 to the 4th. Okay, so there you go. You should be able to simplify and evaluate your logarithms there. I guess not simplify isn't the right word. Evaluate is the word we would use here because we're finding the value of the x in the expression.